And now it's our last full session before the wrap up, and really excited about this. Just a couple weeks ago, the OWASP NHI Top 10 was released, and here we have an in-depth session covering it, presented by Andrew McCormick. Andrew is a great guy, first of all. I've met him, I've got to hang out with him, and he's a really experienced cybersecurity architect. He's been the last decade building secure, resilient systems for Fortune 500 companies. You can find him at a lot of conferences doing a lot of interesting talks, not just on this topic, but a lot of others. He also contributes to efforts like the CSA Top Threats Working Group, which means he's trying to give back to the community. And he wouldn't object to tasting a fine whiskey with you. Let's be honest. So without further ado, let's bring Andrew on stage. Andrew, welcome. And the session is yours. Take it away.
Sounds great. Thanks, Apurva. Let me just get my slides shared real quick. All right. So as Apurva said, I'm Andrew McCormick. I'm a principal solutions architect at Aembit. I spent my last 10 years doing all kinds of systems engineering, SRE, DevSecOps, security engineering, wearing whatever hat I needed to wear in hybrid, cloud, on-prem, and even distributed edge environments like retail stores. So I've got a lot of time spent on the non-human identity space, and I'm really excited for this topic today, which is the OWASP Top 10 for non-human identities. I was really happy to see this drop, and it's great to see the industry start putting more focus on non-human identities. So I'm just going to start with some quick statistics. I don't want to spend too much time on this because you've probably heard a lot of this today. But 21% of the breaches that Verizon looked at in their last DBIR started with stolen credentials. 60% of the keys that Datadog looked at across the cloud providers are over a year old. 54% of the breaches that CISA looked at in their latest RVA were caused by compromise of valid accounts. And 90% of the compromised secrets that GitGuardian found in their state of sprawl were valid for at least 5 days after being leaked. So here's the list, and without any further ado, let's go into it. This list is ranked by 4 high-level criteria: exploitability, how easy is it for an attacker to get in there and take advantage of this; prevalence, how widespread is it; detectability, can our SOC detect when an attacker has exploited it; and then technical impact, what's the impact to our infrastructure and services as a result of this. There is a 5th criteria of business impact, but I don't really bother mentioning it because the answer to every single one of these is it depends on your business. And so for each one of these pillars, I am going to go over an example of a real-life breach that happened that involved this issue here, and talk about some mitigations. One thing that you'll notice as I go through here is you'll see some common patterns in the mitigations here. And so let's jump in. First on the list, improper offboarding. So there's a whole life cycle that we have to manage with our workloads and really all of our identities, human or not. And one of the common steps that gets missed is deprovisioning, offboarding. And so we end up with a lot of identities and secrets and things like that that are left out dangling that can be used by attackers to get into our environment. An example of this is the Internet Archive breach that happened just a couple months ago. So this all started with a misconfigured GitLab repository that exposed an access token for 22 months. And then attackers managed to get that token and go through some code, and they found a bunch of secrets hard-coded in the repositories. They exfiltrated 7 terabytes of data, and amongst that data were some long-lived Zendesk credentials that they found. Those credentials were used multiple weeks after the original breach had been discovered, but they had not been rotated yet. And so the attackers were able to use these to get into the Zendesk environment and compromise all of the support tickets all the way back through 2018. So some mitigations here is incorporating full lifecycle management into your workload provisioning processes. Whatever you're using to provision your workloads, whether it's Terraform or some process that you've put together, you need to make sure that that process also includes deprovisioning so that we're not leaving these things dangling to just get picked up and abused. Leverage identity-based access and ephemeral credentials. All of these, long-lived credentials that need to be rotated, secrets getting hard-coded into scripts, all of that kind of stuff. We can move away from that if we just treat workloads like we treat our humans, right? Identity-based access platforms. And then the reality is that not everything can support identity-based access or ephemeral credentials. And so when you do need to use long-lived credentials like API keys, you should automate the rotation of them, and you should store them securely in password vaults, secrets managers, things like that. And then finally, regularly audit all of your non-human identities and their owners so that you can find those things that are dangling and clean them up. All right, number 2, secrets leakage. Exposed secrets are like leaving the keys in your door. They're everywhere. They're in GitHub. They're in document pages. This has been a problem for a long time, and it's getting more and more obvious. An example of this is the New York Times breach that happened back in June. The initial attack leveraged a publicly leaked GitHub token, and then they were able to use that GitHub token to, again, get into the repositories and find secrets that were in source code. And using the source code and the secrets, they were able to extend into other systems, and they were able to leak New York Times education user data and hundreds of secrets in addition to the source code itself. So again, mitigations here: leverage identity-based access and ephemeral credentials. You're going to get tired of hearing me say this one. Automate rotation and store long-lived credentials in secrets managers. You'll probably get tired of hearing this one too. Automate secret detection. Start scanning your code repositories and documentation and things like that to find these secrets that are out there so that you can proactively clean them up before they get abused. And finally, enforce least privilege. There's nothing new about this. We've known we need to do this forever. And it's something that we need to, as an industry, get better about. Vulnerable third-party non-human identities. So in the world of SaaS and multi-cloud and all of the other layers of complexity that we've got today, third-party integrations are everywhere. They're on developer IDEs, they're SaaS to SaaS, cloud to cloud, all over the place. And we need to kind of get a handle on them. An example of this is the Cloudflare breach in 2023. This actually originally started with the Okta breach that happened in 2023. And when Okta got breached, the attackers were able to steal tokens and service account credentials from Cloudflare's Okta environment. And then Cloudflare did a great job. They rotated over 5,000 credentials in response to this breach, but they missed 4. Those 4 keys allowed the attackers to access Jira, Bitbucket, and Confluence, and they were able to leak sensitive data, source code, and other things like that. So some mitigations here: you should be vetting and limiting third-party integrations as much as possible. This is not always easier said than done, but we need to be performing security reviews for this stuff. Monitor and analyze your third-party behavior. Use your SIMs and UABA tools and things like that to identify anomalous behavior that could indicate that a non-human identity might be used by a human or an attacker. And then finally, again, leverage identity-based access and ephemeral credentials to make abuse of credentials harder. Insecure authentication. There are still so many APIs out there that only support long-lived API keys, or username and password with no multi-factor authentication, or even non-standard OAuth and mutual TLS implementations that have vulnerabilities because they don't follow the standards. An example of this is the Hugging Face Spaces breach that happened earlier this year. An API vulnerability was the initial access. It allowed unauthorized access to secrets in Hugging Face Spaces. And some of those secrets were long-lived access tokens that were scoped to an entire organization and were used to kind of run amok. In response to this, Hugging Face did deprecate these org level token scopes and have started moving towards shorter lived tokens. So they are working towards making this better. Some mitigations, again, leverage identity-based access and ephemeral credentials, adopt modern authentication standards like OAuth and get rid of the deprecated ones like the implicit credential grants and things like that. And then conduct application security audits. Insecure cloud deployment configurations. So we've got CI/CD pipelines everywhere. Those pipelines have privileged access because they do privileged things. So the solution here can't be to take privilege away. We just have to do a better job at securing them. An example of this is the Sisense breach back in April. So attackers managed to access Sisense's GitLab environment. It's unclear how the initial access occurred, but once they were in, they found hard-coded AWS access keys in the repositories. And then they used these access keys to exfiltrate plain text customer data, including access tokens, email passwords, and certificates. And so some mitigations here, again, leverage identity-based access and ephemeral credentials, enforce least privilege, avoid hard-coded credentials. And one of the ways that you can do this is with identity-based access, and also with our next point here, which is automate the rotation and store long-lived credentials in secrets managers. There's never a good reason to have credentials hard-coded in your code. There's just not a good excuse for it anymore. Arguably, there never was. Long-lived secrets. So we don't let our human passwords live for a year. Why should we let our workload passwords live for that long? An example of this here is the U.S. Treasury Department breach that happened just last month. So originally this was actually a beyond trust breach. So an attacker gained access to a compromised beyond trust remote access API key. And then they used that API key to get into Beyond Trust SaaS platform. And they found some command injection vulnerabilities. Between the API key and the vulnerabilities, they were able to use this platform to steal documents from Treasury Department employee workstations. It's unclear the exact level of sensitivity of these documents, but the Treasury Department did consider this a major incident. So it's safe to say they weren't nothing. Some mitigations here. Again, leverage your identity-based access and ephemeral credentials. Automate the rotation and store long-lived secrets in secrets managers. And adopt zero trust and least privilege principles. I've talked about least privilege a couple of times, but the zero trust is a really important thing where we need to be thinking about the context of an access request and how we can ensure that a request is valid beyond just they have a credential. Environment isolation. So we've got dev, we've got test, we've got load, we've got stage, we've got prod, and who knows what else. All of these environments need to be segmented. And we can't be using the same identities, the same infrastructure across these different environments, because attackers will find ways into lower security environments and use them to get a foothold into higher security environments, like production. And so an example of this is the Midnight Blizzard attack that happened against Microsoft back in January. The initial access came from a password spraying attack, but that access only gave them limited access into Azure. But with that limited access, they were able to find a legacy OAuth application that was originally designed for testing something. It got set up in a prod tenant to test the integration and never got cleaned up after testing was completed. And so the attackers were able to compromise this OAuth application to get higher privilege in the production environment. And then once they had that privilege, they created additional OAuth apps to create persistence and lateral movement and make it harder to detect their activities. And then they used this to compromise customer emails and data in customers' O365 tenants. So some mitigations here. Strict environment isolation for your non-human identities. Every single service in every single environment needs to have a separate identity. If we start reusing these things, we run into problems, which comes to enforcing least privilege. If you're using the same identity in dev, test, and prod, that's not least privilege. And then segment access to specific environments and segregate your infrastructure for your sensitive resources. And then NHI reuse. This is similar to the previous one, but not focused only on environments. Reusing non-human identities, service accounts, API keys, things like that across multiple applications and environments prevents proper least privilege and non-repudiation. An example of this is the Imperva Cloud WAF breach back in 2019. So the way that this breach happened was Imperva was testing some new architecture for their Cloud WAF that was supposed to increase performance. And as part of that testing, they took a snapshot of a production database to use in their test environment. They also set up an EC2 instance that was internet exposed and had a production AWS access key in it. And the attacker was able to use the access key to compromise the customer data in the snapshot, which was a production snapshot. And so as a result, they were able to get customer data and secrets out of this. Mitigations are very similar to the last one. Assign unique non-human identities to each application, system, or service in each environment. Enforce least privilege and regularly audit all of your non-human identities and the humans that set them up. And then human use of non-human identities. Your admins shouldn't be using non-human identities. Your admins should have human identities that they use that are tied to them specifically. An example of this is the Circle CI breach back in December of 2022. This all started when malware was deployed to a Circle CI engineer's laptop. And then with that malware, they were able to steal session cookies, and those session cookies were able to generate production tokens for workload identities in production, which then was used to exfiltrate customer data, including tokens and keys. So mitigations here: use dedicated identities for your humans versus your non-humans. Audit and monitor your non-human identity activity for anomalies. Try and detect when a human is using a non-human credential. Use context-aware access controls that can, help you make that determination of if this is a human or not. Falls into that zero trust category. And then finally, educate your developers and your administrators about why they shouldn't be doing this and what problems it causes. And then a quick summary to wrap it up. You'll notice here that there were some repeat patterns. Number one is wherever you can, you should be replacing long-lived secrets with ephemeral credentials and identity federation. We started doing this with humans a long time ago, and we need to start moving in this direction for our non-humans more and more. As the more we treat this as a secrets management problem, the more we will miss the fundamental identity risks that we're ignoring. And then automate rotation of your long-lived credentials, because the reality is we live in a world where you can't use ephemeral credentials and federation everywhere. It just isn't an option. and store your long-lived credentials in secrets managers, IAM platforms, things that were designed for this. An extra plug here for the vendors out there that are running APIs and things like that. Please stop using long-lived credentials. And number 3, implement scalable processes and tools for managing the full lifecycle of your non-human identities. And number 4, enforce fine-grained least privilege. And finally, audit, inventory, and review all of your non-human identities and their permissions regularly.
That's it, Andrew?
That's it.
That seems like only like 10 years worth of work for people. I don't know.
Yeah, it's nothing. I want to give a shout out to all the people that contributed to this project, because having this list is huge. It's a great way to highlight the things that some of us practitioners have been banging our heads against the wall on for a really long time.
Yeah, I agree. OWASP did a great job coordinating this. We have a few minutes left, so let's get into questions. I believe you started to answer this question, but it came from the audience, so I want to ask it specifically. The question is really, these mitigations you've shared, can they be automated? Like, there's a lot of talk about how we need to just do things, right? Like change our code so it doesn't have long-lived credentials, rotate those credentials, audit these things. How do you think about automating this stuff so that humans can actually scale to the number of non-human identities that are out there?
That's a great question. This is something that the industry needs to help with, and that it's something that we are working on at Aembit. But I see there being kind of a two-pronged approach. For your long-lived credentials, it really comes down to having robust processes and understanding these credentials so that you can automate them safely without breaking your applications and putting them in secure places. And then moving towards what the future looks like is dealing with these platforms that create a centralized federation layer. You can kind of think of it as the equivalent of single sign-on for workloads. That's what I think the industry is moving towards, and I'm hoping we see more and more progress on that in the years to come.
Yeah, okay, that's great. So actually, less of a question. Well, maybe I'm going to turn this into a question because it's really good. It's one of the first where they're saying "nah" to a presenter, where you made a comment, which is humans have moved away from long-lived passwords. One of the audience members says that we actually do let humans have long-lived passwords, and password rotation was kind of deprecated or debunked by some research a while ago. I'm just wondering if you have a reaction to that, if you disagree, or if you agree, and that tells us something else about non-human identities.
Yeah, I do agree with that, but I think that is not something that has happened in a bubble. That is something that, at least in my opinion, has happened in lockstep with multi-factor authentication, things like FIDO2, passwordless authentication. And so as we have strengthened the other aspects of a human's authentication, you're right. We have moved further away from this idea that you must rotate your passwords frequently. I think the other bit about this that is unique to humans is that because humans have to remember these things, rotating them frequently causes a problem that is unique to humans that workloads don't have, right? Mm-hmm. If you're a workload reading a password from a vault, you don't care if that password is 5 minutes old or 90 days old. You don't have to remember it. You just have to be able to get it.
30 seconds left. Is there anything that wasn't on the top 10 list that you think should be there?
So this is one thing that I have been thinking about a lot. Is I spent a lot of time in the retail environment at the distributed edge, when you've got physical machines with no physical security, and you might not even have any kind of centralized identity provider or domain or anything like that. And they're still non-human identities. They still need access to services. And so I think one of the things I would call out is weak identification of your workloads for the purpose of attestation, authentication, whatever you want to call it.
That's great. Andrew, we're at time. I just want to thank you so much for this. It was a really great breakdown of something that was pretty new out here. Like this NHI OWASP Top 10 was just released earlier this month. So I think you're giving people a great head start on tackling these problems. So thank you so much. For our audience, let's head to the closing session. We have some great wrap up and some commentary from our partners at IDSA and CSA. So we'll see you over there. And in the meantime, thank you again, Andrew, and hopefully the audience will get to see you again soon.
Thank you.